All right, lesson 6.7. Lesson 7 is patterns and scatter plots. I know the notes seem long, but it won't take us long, and I really want you to have a lot of good examples um, because now this is dealing with real life data, and real life data isn't perfect. And so we're going to have to make some decisions based on what we're given. So, excuse me, it says in a previous lesson, you learned that scatter plots show trends in bivariate data. Okay, bivariate, two different pieces of data. So when you look at a scatter plot, you got to ask yourself these following questions. Does it look like there's a relationship? Okay. If there's a relationship, does it appear to be linear? Remember, a straight line. And if it's linear, is the relationship positive linear or negative linear? So to answer the first question says look for patterns in the scatter plot. Does there appear to be a general pattern to the points? We are not playing connect the dots. It will not look like a perfect straight line. But in general, if you step back and look at it, does it kind of look like the data is all going in one direction, or is it all over the place? Now, if you see a pattern, do you think it would be well described by a line? Meaning, okay, can we draw a line that is not the same distance from all the points, but seems to fit the points? Now, the third question requires you to distinguish between a positive linear relationship and a negative linear relationship. A positive linear relationship is one that is described with a positive slope. A negative linear relationship is one that's described with a negative slope. Okay, and again, keep in mind we're always reading graphs from left to right. So the next few examples is we're just going to be going through those three questions, okay? And hopefully you kind of start to see what the relationship is. Okay, so number one here is the relationship. Okay, now if you look at these, again, we're so used to looking at like straight lines or nice curved lines. This can kind of be weird to look at. And we're like, well, right here it kind of does, but it doesn't. No, step back, look at the whole thing. Does it appear as our x values increase that something is happening to our y values? Are they all increasing or all decreasing? So if I kind of look here, it's not perfect. But as we go from left to right here, they all seem to be decreasing. So I'm going to say yes, there's a relationship. Does it appear to be linear? I think so, because I can kind of draw a line through here and it would kind of like go through the middle of the points. Not that that's always the best thing. We'll talk about that later. So I'm going to say yes, kind of. Okay. And in statistics, it's your job to kind of figure out if there's a relationship or not. So if it appears to be linear, and I kind of said yes, kind of, is it positive or negative? Here's the deal. We're always going, the x is always increasing. We regraph from left to right. Is this trend going up or down? It's going down. Our slope is going down. So this would be a negative relationship. Okay. And this is all we're doing for the next few examples here. Just trying to get used to looking at different types of graphs, scatter plots. So is there a relationship here? So again, big picture. As our x values are increasing, does it seem like there's a trend? I think so. Okay. It kind of seems like they're all going up. Maybe not the same rate, but it does seem like they're increasing. So is it linear? Yeah, I think it is. Okay, drawing a line right here. And now, if we're going up from left to right, our slope is positive. So we'd say that this is a positive linear relationship. Okay. All right, now let's take a look at this next one. Okay, is there a relationship? Step back. As our x values are increasing from left to right, do they tend to be doing the same thing? Maybe not the same rate, but the same thing. No, I'm not seeing it. Okay, so I'm going to say no. And so then the next questions, well, they only apply NA, and slash A there means not applicable. They don't apply because there's not a relationship. Okay, and that's real life data too. Okay, if you were a scientist or doing some statistical analysis, that might be information for you. All right, let's look at this one. Is there a relationship? This one's kind of interesting because my first thought wants to be no. But as our values are increasing from left to right, they start here, they kind of go down. I know we're not doing this yet, but do you kind of see how they're kind of following this curved line? So I'm going to say yes. Okay, because they kind of seem to be doing the same thing. It's not like they're dropping back down. It's not randomly placed anywhere. So if there's a relationship, does it appear to be linear? No. Okay, this is looking like one of those curved lines. And if it's linear, well, remember it's not. So not applicable, not applicable. NA. I just won't even try to say that word. Applicable. There we go. All right. Okay, so I'm not gonna lie. This one I might have had some disagreements on my answer key. Yes or no? Well, again, as our values move from left to right, I don't know. My answer key says yes. I don't know if I'm seeing it, so I'm going to go yes, question mark. All right, so I kind of can see that they are kind of falling as you go left to right, but it just is a big group here in the middle. So I'm going to say yes. Same thing here. I'm going to say yes, wincing with the question mark. Okay. If I were to think of it as a linear relationship, I would say it's negative. Okay. So if I'm going to think of it those things, I am going to say they're negative. Okay. So look at, we did all of those examples pretty quickly, hopefully not too quickly. But again, we're not looking at perfect straight lines here. We're looking at real life data, and we're trying to see if there is a statistical relationship between them. Okay. So now let's take it to the next step. Okay. Now we need to take it to the next step. And it says, below is a scatter plot on weight in pounds and fuel efficiency. Okay, we've kind of done this before, right? For 13 cars. Using the questions at the beginning of the lesson as a guide. Okay, so let's go back up to our questions here. Does it look like there's a relationship? If there's a relationship, does it appear to be linear? And if it is linear, is it positive or negative? Okay. Write a few sentences describing any possible relationship between X and Y. And to make your life easier, I am going to type so you don't have to read my handwriting. But first, we're going to look at this. Does there appear to be a relationship between weight and fuel efficiency? So again, as our weight is increasing, what is happening to our fuel efficiency? There seems to be a relationship there, doesn't there? I mean, it's pretty tight. Like of all the ones we've looked at, this looks like to be a pretty strong relationship. And as our weight is increasing, our fuel efficiency seems to be decreasing. Yep, not perfect, I get that. But there really appears to be a strong relationship between these two. So let's say that. There appears to be a strong negative, right? Because it's going down from left to right, negative slope. Linear relationship. And I'm covering that all in there. Negative and linear. Okay. Now, we always want to say something about our labels, our axes, about our bivariate data, right? Data, whatever. Like we want to compare weight and fuel efficiency. We don't want to say it's going down. Well, what is it? So my second sentence here is going to say the cars with the greater weight tend, not always, but tend to have lesser fuel efficiency. Okay, we want to make this. And you can always, it's kind of a hint for you here. You can always say, well, as the weight is increasing, always say whatever's on the x-axis is increasing. Then you can say, then tell what's happening here. The y-axis, whatever the label is, in this case, fuel efficiency is decreasing. Okay, so using those two questions, is a relationship, is it linear, is it positive or negative, kind of helps us describe what's going on in the graph here. Okay, so let's look at the next example. Below is a scatter plot of data on price in dollars and quality rating for 14 bikes. Using the questions again, write a few sentences. I don't know if I'm writing a few sentences here, but let's look at it. Step back, look at the big picture. As our price is increasing, is our quality rating going up, going down, curving? Nothing. It just kind of appears to be all over the place, right? I'm struggling to see any type of relationship. So let's say that. There does not appear to be a relationship between, I always say what we're talking about here, our data, price and quality rating. Okay. It's weird. Sometimes math isn't about numbers, right? We're doing a lot more writing than we are anything with numbers. Okay, 2 more examples, please. Okay, below the scatter plot is on shell length in millimeters and age. Okay, so of a lobster. Okay, 27 lobsters. Shell length and age. So as our shell length is increasing, what is happening to our age? Okay, well, I kind of getting like a curve here. Do you guys see this? Okay, sorry, it's not going to be nice curved line there, but I think there's a stronger relationship. Okay, I think as our shell length is increasing, so is our age, but I don't think it's happening as a linear relationship. So let's say that there appears to be a relationship, and I'll try to spell correctly, between shell lengths and age, but it is not linear. Now, if we added some more lobsters there, I could be wrong. The age is increasing, but not at a constant rate. Because if it was constant rate, then it would be linear. Okay? All right, one more. Okay, so again, we said there's a strong relationship here, but it's just not a linear. That's okay. Below the scatter, apply the data from crocodiles in body mass. Oh, there's back to crocodiles and bite force, right? So, as our body mass is increasing, what is happening to the bite force? So, do we think there's a relationship here? Okay, I think so. Yeah, there's some that kind of appear to be outliers here, but it really seems like there's a relationship right here. And I think it's linear. So, to finish up, there appears to be a positive, right? That's our third question there. Linear relationship. As, because here it comes, right? Not mentioning our variables. As body mass increases, so does the bite force. Whew. I know that was a lot, especially that we're not dealing with numbers or anything. But we're learning to look at real life data, okay? And we're looking for relationships. And if there is one, we want to be able to talk about what type of relationship that is.